Alright, we're doing section 4.6, factoring quadratic polynomials. And if I'm quieter today, because it's early in the morning and somebody is sleeping. Hopefully not you. So today's question, how do we factor quadratic polynomials? What is a quadratic polynomial anyway? All good questions. Now, the notes today are somewhat incomplete. There are going to be things I'm adding. There's going to be stuff that's not written there. Might be a problem that's not written there. You'll just have to stick them in yourself. So quadratic polynomials. A quadratic or second degree polynomial looks like this. So you have an ax squared term plus bx plus c. The ax term is called, the ax squared term is called the quadratic term because it's got the square in it. Bx is the linear term because the x is only the first degree, so it's like a line. C is the constant, it's just a number. A quadratic trinomial is a quadratic polynomial where a, b, and c are all non-zero integers. If you have a 0 for b or c or a, you're going to get something else. And you won't always factor them the same way. You might have a special trinomial like a difference of squares if you have like an a and a c. But for a quadratic trinomial, we're going to have coefficients for all three terms. Now, the book has a certain way of factoring these quadratic trinomials, and since you've done this in Algebra 1, you should have some comfortability with doing this. Whether you want to use any of these methods or you have one that you like, pick the one you like, go with it, but keep in mind that time is always going to be an issue on a test, and you have to work quickly. So if you have a cross method or a box method, which I'll show, and then what I use pretty much just powering it through quickly, whatever works for you is whatever works for you, but keep in mind that time is limited. If a quadratic polynomial ax squared plus bx plus c can be factored into the product px plus q times rx plus s, where all four of those variables are integers, then ax squared plus bx plus c equals px plus q equals times rx plus s, or prx squared plus the quantity ps plus qrx plus qs. So a equals pr, b equals ps plus qr, and c equals qs. This is basically the fundamental principle of what we're doing, and they're all going to look like that. It's just how you do it might look different. So another way you can do it is if a is 1, it's going to have something that looks like this. Two terms, each in x, if it's something that can be factored. Of course, if it's prime, which we'll get to in a moment, then you can't do this. You're going to want to find factors of c that when multiplied equals c and that add up to b. If c is negative, this term is negative, you're going to have a factor that's positive and one that's negative. If c is positive, they're either both positive or both negative. Then you're going to want to use those factors and plug them in, making sure that whatever the factors do, they add up to this b term. If a is greater than 1, then you can use the box method or another method I will show you on a blank screen, or I'll probably show you in class the next day because it's kind of hard to draw on a PowerPoint slide. So example 1, we have to factor x squared minus 2x minus 8. So since a is equal to 1, you can find the factors of negative 8 that add up to negative 2. Since c is negative, you have to have one positive, one negative. So here are the factors of 8. We have 1 times negative 8, negative 1 times 8, 2 times negative 4, and negative 2 times 4. And as you can see, it's highlighted by yellow. These are the only two factors that add up to the linear term, negative 2. So you take a positive 2, and you take a negative 4, and what you have to do is remember it's going to be x plus 2 times x minus 4. And if you actually refoil this, you'll get x squared minus 2x minus 8. So you take the factors of the final term. If a is 1, look for the two factors that when added up together equal the b term, keeping in mind that if c is negative, you have to have them of opposite signs. Alright, prime and irreducible polynomials. Not all polynomials are factorable. If a polynomial cannot be expressed as a product of other polynomials, it is said to be irreducible. An irreducible polynomial with integral coefficients is prime if the greatest common factor of its coefficients is 1, which basically means if something can't be factored, it's going to be considered prime. So take a look at example 2. Factor y squared plus 3y plus 4. having gone over this, you would expect this one, it'll probably be prime because I just talked about it. So you have a equals 1 and c equals 4. So you have to look for factors of 4 that add up to 3. And they have to have the same sign because c is positive. So you have 1 times 4, negative 1 times negative 4, 2 times 2, and negative 2 times negative 2. Well, guess what? None of them add up to 3. Since none of the factors add up to 3, then our quadratic polynomial y squared plus 3y plus 4 is prime. So this is pretty simple. If something can't be factored, it's prime. But don't assume something's not factorable just because you tried a couple numbers. Make sure that you exhaust all possibilities before you make the conclusion that it's prime. Because if it's not prime and you call it prime, you're going to lose all the points. Let's go to example 3, y squared plus 14y plus 15. Again, the exercise is to take factors of 15 that add up to 14. Here they are, and as you can see, none of them add up to 14. So again, the expression is prime. Alright, example 4, y squared minus 14y plus 13. Now, again, with all these examples, if you understand these and you have your own way to do them, go for it. And you don't have to wait for me to teach you how to do it. You can just kind of skim ahead to the finish, look at the slides to see if your guesses are correct. You can save yourself the time of me listening to me babble on. So again, we have a c value of 13 because a is 1. We can just look for factors that add up to negative 14. So you can probably guess they're going to be negative, and with 13 being a prime number, it's pretty easy. We're going to choose negative 1 and negative 13. So all you have to do is take negative 1, negative 13, put it in the factoring terms, and you get y minus 1 times y minus 13. So it's pretty simple when you have a coefficient of 1. You're just going to power through. And you don't have to always write out all the factors. If you can see them right away, just do it right away. You don't always have to show work. Now, this is an important concept because factoring completely is something that a lot of students don't always do. A polynomial is factored completely when it is written as a product of factors and each factor is either a monomial, prime polynomial, or a power of a prime polynomial. In other words, you can't end up with something like this. 3 times the quantity x plus 3 minus 4. This minus 4 is a problem because what you have to have is everything multiplying together. You can't have dangling things you're adding or subtracting. You have to make sure that everything's either in parentheses or something like this where everything is multiplied together to generate that polynomial. If you end up with this, you need to go back and see if you can think of it a different way. Example 5. Factor r squared minus 7rs plus 12s squared. Again, you can go ahead and try these on your own. And here comes the answer. Since c is 12, both factors have to be the same sign. Now, you have this r thing in there, but don't let that mess you up. All that means is that you're going to have an r and an s in the final term, but you're treating it the same way. So, here are your factors of 12. And again, you're looking for two factors that add up to negative 7, and there they are, negative 3 and negative 4. So, when you write up your factors, don't forget the s on the end. Don't let it fool you. Make it harder than it is. R minus 3s times r minus 4s. Alright, example 6. We factor 2m squared minus m minus 1. Now, for the first time, we have an a term that's not 1. C is negative 1, so you have to use a different method. But because the only factors of 2 are 2 and 1, you know the two terms have to start out with a 2m and an m. And the second terms have to either be a positive 1 or negative 1. So all you need to do is a trial factorization. And you don't always have to write these out. You can just kind of look at them numerically and try to figure out the answer. So you either have 2m plus 1 or m times m minus 1. Or you have 2m minus 1 times m plus 1. If you do that, if you check the linear term by using the o and I parts of FOIL, you get a negative 2m there and a plus m there, so that leaves you with a negative m. You have a negative m inside and a positive 2m outside, which leaves you with a positive m, which means this one is the correct answer. So you end up choosing that one, and that is your correct answer, because you can do these when you have simple numbers, especially when you have a prime number or something with just a few factors on the first term. You can kind of go through these very quickly. Now, I'm going to show you a different way, probably in class, because it's too hard to do over PowerPoint again. That'll make it go a little faster, but you have to be very comfortable with the numbers and be comfortable working quickly. Example 7, factor 3z squared plus 10z plus 3. So again, you can do a trial factorization. And again, this is the way I recommend it. You just don't always have to write out all the work because it's kind of a pain. So you know that A is 3 and C is 3. So the only factors of 3 are 1 and 3. And since the middle term is positive, the factorization has to be either 3z plus 1 times z plus 3 or 3z plus 3 times z plus 1. You don't have to worry about using negative signs to generate the positive c because you know the linear term is positive. So you have to have two positives. Well, based on choosing one of these two, you're going to choose this one because that's 10z. And so what you can do, and I'll show you in class, that you can basically write out the 3z and a z and then just try to 3 and 1 there, and then try to cross them until you see a combination that gives you the sum of the linear term that you need. And again, I'll show you that in class. So again, the yellow one is our answer. Factors of 3 make it easy enough to do the trial and error. Now I'm going to do something called the box method. Some of you guys might have used this before. But this is a different way that you can use to factor quadratic polynomials if they have big numbers, especially with A and C. And I'm going to let you read these because you guys can read a lot faster than I can talk. And you can pause if you need more time to read it. Here are steps 4 to 6. And it'll be a lot easier for me to explain using an actual example than for me to just read it right now. So you can stop the video if you need to read it because I'm going to advance to the next slide right now. Here's example 8. You're going to factor 5r squared minus 10r plus 7. So the step 1 is to factor out any constants. So there are no constants, so you're left with what you started with. For step 2, you're going to multiply a and c together. And you want to note whether the product is positive or negative. So 5 times 7 is 35, and it's positive. So both numbers must be positive or negative. They're going to end up being negative if they work just because the linear term is negative. Next, you're going to try to find two factors of a times c, which is 35 in this example, that add up to b, which is negative 10. And as we talked about, if ac is positive, both factors must be positive. Since ac is positive, we can worry about that one. And the factors of 35 are pretty simple. You have to have two negative factors because your linear term is negative. So you either have negative 1 times negative 35 or negative 5 times negative 7. Since neither of those add up to the desired negative 10, the polynomial is prime, and you're done. So perhaps this wasn't the greatest example to use the box, because this is something you would do whether you use the box or not. So I'm going to pick an example from the book, and this is the one that's not listed on your sheet. You're going to factor 4y squared minus 17y plus 15. So I'm going to do the first step, factor out any constants. There are none, so we can go to step 2. Step 2, you're going to multiply a and c together. So here we go. 4 times 15 is 60. It's positive, so both factors have to be negative because our linear term is negative. So we're looking for two factors of AC that add up to B. I've listed all of them here. You do not have to do this because obviously you don't have to use a 60 or a 30 or even a 20 because you know none of those are going to work. You're probably going to try something in the middle. And lo and behold, negative 5 and negative 12 are the factors that add up to B, negative 17. So next you're going to draw a 2 by 2 grid and place the quadratic term in the top left box and the constant term in the bottom right box. So there's your 4y squared and your 15. Place the factors you found in step 3, multiply them by x, and place 1 in each of the two empty boxes. So you place a negative 5y or negative 12y. Instead of x, of course, we're using y. It doesn't matter which box you put them in because when you factor it, you'll end up with the same answer. Because in step 5, you're going to factor both rows and both columns. So you factor this row and you look for a common factor. So here it's just a y. So you factor out the y, you write it down here. Here, you're going to factor out a negative 3. You're always going to take the negative if the first term has a negative. So since it's negative and there's a common factor of 3, you factor out a 3. You do the same thing with the columns. You see a 4 and a y, so you take out the 4y. And here you have a common factor of 5. So you take negative 5 because the linear term here is negative. Step 6, all you do is take the factor of both rows and combine them into one factor. So the columns, 4y minus 5 go here, y minus 3 go there, and you're done. So the box method is a little slow, but for some of you it might be the best way to get the most accurate answer instead of something that's quicker and dirtier. Alright, and again, I'll show you a different method on how to do this in class. See, this video you're watching on Thursday night, I'll show it to you on Friday. Alright, the GCF and the LCM. We've done this before. Now we're going to do it with polynomials. The greatest common factor of two or more polynomials is the common factor having the greatest degree and the greatest constant factor. The LCM of two or more polynomials is the common multiple having the least degree and least positive common factor. Alright, it's probably actually easier to look at examples. So let's take a look at example 9. Find the GCF and LCM of 6y squared minus 6y and 4y to the fourth minus 24y cubed plus 20y squared. Alright, so you're going to want to factor both terms. You can go ahead and do that now. If you want to pause the video, that's fine. So, factor both of them completely. You'll take the 6y squared minus 6y. You can factor out a 6y, and you get 6y times whatever's left inside, which is y minus 1. For this one, you can factor out a 4y squared right away. So you get 4y squared, and what you're left inside the parentheses is y squared minus 6y plus 5. You can further factor this quadratic, and you'll eventually get y minus 5 times y minus 1. And again, if you do enough of these, and you're going to have to do a lot of problems, you will start to see patterns emerge where you don't have to always go through the box or do trial and error. You can just kind of see it right away. Alright, let's keep going. Those are our factors. Now we're going to try to examine the greatest common factors. So, the greatest common factor of the monomial factors is 2y. So, you have a 6y here and a 4y squared. That's the first step. Look at the monomial factors. A 2 goes into both 4 and 6. A y goes into both y and y squared. This is the same thing you did back in section 4.4. Now we look for the greatest common factor of the binomial factors. Both of them have a y minus 1 term. So again, you take the common factors that have the least degree. So both of them are the first degree, so you just have a y minus 1. So you put those together, and your greatest common factor is 2y times y minus 1. So again, what you're going to do is take the monomials, look for the GCF, the same way you did back in chapter 4, section 4, and then look at the binomial factors, which is pretty simple. You're basically looking for things that match, and again, you're going to take the least degree. Now for the least common multiple. We're looking for the least common multiple between 6y and 4y squared. First, you have to do it for the number, and if you factor it, or you just kind of see it, you'll notice that the least common multiple of 6 and 4 is 12. Plus, for y and y squared, remember you take common factors and you take the highest degree. So the LCM of the monomial factors is 12y squared. For the binomials, you have to make sure every factor is included, just like you did when we did LCM of numbers. Here we have a y1 in both of them, so we'll have one of those, but we'll also have to include this y minus 5 term. So the LCM is y minus 1 times y minus 5 of the binomials, because you have to take the greatest number of times that occurs in either factorization. So the LCM is 12y squared times y minus 1 times y minus 5. Alright, so that's a lot of stuff that we went over today. You'll have a chance to practice doing these questions in class. I want to again raise the idea of factoring completely. Notice that when you factor out this second one to get to this, you don't have any things that are just kind of hanging out like plus 1 or plus 2 or minus 1. Make sure everything is a product of something. Alright, that concludes this long video. If you have any questions, ask me in class the next day, and I will show you another quicker way to do it that's basically the same as some of the other ways, but it just goes faster.